You jump, not a normal jump. This is a jump with escape velocity, 11.2 kilometers per second. The ground does not just move away, the ground vanishes. Your shoes stay behind. They are now a small crater in the suburban driveway. The air is no longer a gas. At this speed, the atmosphere acts like a solid wall of concrete. Compression happens instantly. Air molecules cannot move out of the way, they slam into your chest. The friction generates heat, a lot of heat. Within milliseconds, the air surrounding your body turns into a glowing sheath of incandescent plasma. You are now a human meteor traveling upward. This is suboptimal. Thermodynamics is not kind. The plasma envelope reaches temperatures hotter than the surface of the sun. Your clothes vaporize in a fraction of a second. Skin turns to gas. Muscle becomes carbon. The process is so fast that your nerves cannot even send a pain signal to your brain. By the time the signal arrives, the brain has already melted. This is the efficiency of extreme kinetic energy. You are no longer a person. You are a streamlined column of superheated organic debris. This column is still moving at 11 kilometers per second. Gravity tries to pull back, but the momentum is overwhelming. The atmosphere becomes thinner, which actually makes the heat problem slightly worse before it gets better. Quite bright. The air finally runs out. The screaming heat stops. Silence takes over. You are now in the vacuum of space. The charred remains of your body are frozen instantly. Thermal radiation carries the heat away. You have successfully left the atmosphere. Now the real problem truly begins. Escape velocity is a one-way ticket. There is no brake pedal in the void. Gravity is still there, but it is losing the fight. The distance between you and Earth increases. You pass the International Space Station. The astronauts see a streak of carbonized human ash fly past at 25,000 miles per hour. They probably report it as a strange piece of space junk. You are not orbiting. Orbiting requires sideways velocity. You went straight up. This is called a radial trajectory. It is the least efficient way to travel. You are basically a very expensive, very dead bullet. The sun is now the dominant gravitational force. The solar wind begins to strip away the remaining atoms of your carbonized skeleton. You are becoming part of the interstellar medium. The void is remarkably empty and very cold. It is a very long walk home. The journey continues. Months pass. The Earth is now a tiny blue dot. The solar system opens up. You are headed toward the outer rim because you had so much energy the sun's gravity cannot stop you. You are on a hyperbolic trajectory. This means you are leaving the solar system forever. You pass Mars. It is red and indifferent. You pass Jupiter. The massive gravity of the gas giant tugs at your ash, slingshotting you even faster. You are now traveling at a significant fraction of the speed of light relative to the local neighborhood. The stars stop twinkling. They become sharp points of light. The distance between stars is vast. Light years are the only way to measure this boredom. You are a cloud of atoms crossing the great nothingness. There is no one to talk to. There is no air to breathe. There is only the momentum of that one very powerful jump. It is a very lonely trip. Space is mostly just empty. The silence is absolute. The darkness is complete. You are just drifting. Millennia pass. The solar system is a memory. Your atoms are now scattered across a light year of space. This is the ultimate dispersal. You are no longer a body, but a thin mist of carbon and calcium. Eventually, this mist encounters a molecular cloud. Gravity begins to work again, but on a cosmic scale. The cloud collapses. New stars are born. Your atoms are incorporated into a protoplanetary disk. A new planet forms. It is a rocky world with a strange purple atmosphere. An alien species evolves. They build cities. They develop mathematics. They wonder about the origins of their world. One alien geologist finds a strange concentration of carbon in a cliffside. He analyzes the sample. He finds a chemical signature that looks vaguely like a human from the 21st century. He writes a paper about it. The paper is ignored by the scientific community because the evidence is too thin. The geologist is told his data is noisy. He is denied a tenure-track position. His colleagues laugh at his theory. He spends the rest of his career studying boring rocks instead of intergalactic humans. It is a professional tragedy. The universe does not care about your jump. It just absorbs you into the background noise of a trillion dead stars. Very sad. So can you jump high enough to escape orbit? Yes, but you cannot do it in sneakers. The kinetic energy required would turn your legs into a nuclear explosion. The impact on the driveway would level the entire city. The atmospheric friction would turn you into a streak of plasma. You would eventually become part of an alien planet's sedimentary rock. It is a very effective way to travel, provided you do not mind being vaporized, frozen, and then ignored by a purple alien geologist. It is quite a trip. However, there is one final problem. Your jump technically constitutes an unauthorized launch of a spacecraft. The Federal Aviation Administration is not happy. They issue a massive fine for failing to file a flight plan. The fine is sent to your grieving next of kin. What happens if you try to swim in a pool of liquid nitrogen? Subscribe to the What If Club to find out. Stay curious. Please do not try this at home.